Today, more than 300 precast concrete plants worldwide use Follet technology. We make use of proven components and concepts that ensure successful investments and are extremely reliable. At the same time, we are continuously developing our technologies to make precast concrete plants of tomorrow even better, more profitable and an even sounder investment. We offer you more know-how, more engineers and higher quality service, everything you need to remain in the forefront of your market. This is what we call precast success. The following film gives an example of the production process of double walls and floor slabs. Up to 330,000 square meters of precast concrete elements are produced every year in this production plant in two-shift operation. State-of-the-art technology, intelligent working processes and an adequate degree of automation take place on a compact ground area to ensure high productivity. The first station in the pallet circulation is the cleaning of the pallet that just has been demolded. Concrete remains and adhesives are removed and collected in a bin. After this, the pallet surface is automatically sprayed with separating agent so that the precast element does not adhere to the pallet later. In a final step, the plotter draws the precast concrete parts at a 1:1 scale on the shell surface. The host computer guarantees that all plant components are always fed with the correct data for the element being produced. In the following station, the shutters are set manually. Nowadays, this operation can also be carried out fully automatically, i.e. by shuttering robots. At the same time, other inserted parts such as sockets, windows and door frames are fitted. A special workplace system serves as an intermediary storage for shutters and magnets. The integrated shutter transporter conveys the shutters from the demolding to the molding area, ensuring an optimum ergonomic work process. During conveyance, the shutters are cleaned and sprayed with a separating agent. In the next working step, the reinforcements are inserted manually before the pallet is transported to the concreting area. The concrete is supplied to the concrete spreader by a rotating bucket conveyor, dimensioned for a concrete capacity of 1.5 cubic meters. As is the case everywhere in the production plant, the pallet transversal transport is performed using frequency-controlled cross-lifting cars that first lift the pallets, then transport them across and set them down in the next workstation. An electronic synchronous run control system ensures that both lifting cars are always run in parallel. A gradual turning of the bucket ensures a clean and complete discharge of the concrete. At the concreting station, the pallet is secured on the shaking station before the concrete spreader discharges the concrete surficially into the prepared pallet. The concrete spreader works with an integrated weight measuring system connected to the host computer. A display in the control panel communicates how much concrete must be placed onto the current pallet and what quantity of concrete is necessary for the next pallet. In this way, it is always known how much concrete must be requested from the concrete mixing facility. Afterwards, the concrete is compacted at the shaking station. Our technology allows the compacting energy to be established precisely, also allowing us to process more rigid types of concrete. The advantage for our customers: the production costs are considerably lowered by reducing cement consumption. After a first quality control, the pallet is transported to the curing chamber. A touch panel allows the automatic storage and retrieval machine to be operated intuitively. In this way, each plant component in the circulation can be supervised. After this, the floor-guided automatic storage and retrieval machine fully automatically stores and removes the pallets in and out of the heated curing chamber that contains in total 3 housed racks, each with 10 pallet bays that are placed on top of one another. The curing chamber is completely enclosed so that the humidity and heat needed for the curing does not dissipate. For the storage and retrieval of the pallets, the rack doors are activated using a segmented door opener. The pallets are transported in or out of the rack using friction wheels and a toothed rack conveyor. For the double wall production, the automatic storage and retrieval machine removes the pallet containing the first shell from the rack before it is transported to the turning area. An overhead pallet turning device takes over the first shell. The pallet is locked hydraulically in the turning traverse. The first shell is secured using tensioning arms. Several tensioning units with different heights are provided in order to guarantee that, for example, even concrete elements with core insulation can be produced without difficulty. The shell is then rotated by 180 degrees. After the second shell, which has just been concreted, is positioned precisely, the first shell is lowered using the integrated rope hoist of the pallet turning device. Spacers guarantee that the desired thickness of the precast concrete part is achieved. After immersing the grid irons of the first shell into the wet concrete of the second shell, the double wall is formed by shaking both shells. The synchronous shaking, without any relative movement between the first and second shell, ensures a high product quality and no segregation of the concrete in the reinforced area. After this, the tensioning arms are loosened and removed. The upper empty pallet is turned back and placed in the return position. The finished double wall is transported to the curing chamber. The empty pallet is transported to the demolding area. As soon as the required curing time is reached, the host computer transmits a signal indicating to retrieve the element. Through the middle rack, the finished floor slabs and double walls are removed from the curing chamber and transported to the demolding area. The demolding can nowadays also be carried out automatically by a demolding robot. Using a lifting traverse, the floor slabs are then prepared for transport in dispatch batches. The profiles are placed on the shutter transporter for onward transport to the cleaning station. Here the profiles are cleaned and sprayed with separating agent before they are fed to the workplace system again. In the lifting area, the pre-demolded double wall is tilted to an angle of 80 degrees by use of an overtaking tilting table so that the wall can be carefully lifted from the pallet. An empty pallet resulting from the turning of the first shell can pass directly underneath the tilting table. An indoor crane takes the double wall and transports it to the final position on the supplied loading frames. The transport to the building site takes place by truck.